Hello students, today we're going to take a look at lesson 31, which is multiplying and dividing rational expressions. So I will tell you that this lesson is very similar to just our lesson about simplifying rational expressions. So what we're going to be doing is we're going to be looking at some things, factoring down. Sometimes we'll have to plug in a number, and again, just like before, we're going to be looking for values that would make our entire expression undefined. So remember, for that very specific piece, that is when we would have a 0 in the denominator. So whatever number we could plug in for x in order to get a 0 in the denominator, those are the numbers that will be answers for those types of problems. So a rational expression is blank if its denominator is 0. So that's just exactly what I was talking about. That would be undefined. And then here we're multiplying, so we can cancel things out that are across from one another, or we can multiply straight across and simplify at the end, but I do find that this would be easier. So we have 3 and we have 9, so that would be a 1 and a 3. 5 and 10, that would turn into a 1 and a 2. So that's just going to be 1 times 1 is 1, 2 times 3 is 6. And then remember, if you are dividing fractions, I have it laid out this way for a very specific reason. It's because we are just going to multiply by the reciprocal. I don't know if you've seen the keep, change, flip sort of method. But then again, now that we are multiplying by the reciprocal, we can just cancel out across. So there are 4 5s and 20. 2 times 4 is 8. 1 times 1 is 1, so we just get 8. And then last, we are just going to plug in some numbers. So we have 4 times 3, and then we have negative 2 to the third. So that's first part is going to be 12. Negative 2 to the third is going to be negative 8. So that's going to be negative 96. Okay, there's your warm-up for the day. Okay, so our new concepts. To multiply rational expressions, multiply the numerators, multiply the denominators, just like you would multiply fractions with numbers. To simplify a rational expression, factor and divide out common factors. To evaluate an algebraic expression, substitute given values, and then we'll simplify. So you don't necessarily have to do things in the order that they say here. What I find is most easy is to simplify things by doing that factoring and seeing things that aren't common, and then simplify numbers, or simplify or plug in numbers at the end. So right here we have multiply and then evaluate for when A is going to be equal to 4, B is going to be equal to 5. Now, when these things are being multiplied, I want you to realize that you can simplify things that are either on top to bottom, numerator to denominator, such as this b squared and this b squared, but we can also simplify things that are diagonal from one another. So like this 12 and that 6 would simplify so that I have a 2 left over up there. Okay, and then I'm going to simplify that a and that a, and let's see, we have that b squared and b to the third, so we would have a b left over. So this is everything we can simplify. So we're going to be left with 5 times 2 times a squared all over, looks like just 3b. So we know on the top that's going to end up being 10a squared over 3b. So that would be simplified. Now they give us values for a and b, so that's going to be 10 times 4 squared all over 3 times 5. So we know 4 squared is 16, times 10 is 160, over 15. And let me think. So we know that a we can take a 5 out of both of these numbers. So 160 divided by 5 is 32, and 15 divided by 5 is 3. So that will be our answer for this one after we plug those in. So you kind of get a two-part answer. You get one before you plug things in, and you get one after. So sometimes your number is just, or your answer is just a number, and sometimes it's not, a little bit more complicated. All right, so here we have a problem that will be a tiny bit more complicated because our factors, or our factoring, is going to be a little bit more involved. Okay, so you have to remember all of your tricks to factoring things down, and that's going to be your key to being successful within this lesson. So the very top left, I'm going to save that because we'll just talk about that trick in a little bit. So if we look at the bottom left, we have x squared minus 9. That's going to be x minus 3, remember, because this is a difference of squares, and then x plus 3. Times, remember we have what multiplies to get 15 and adds up to get negative 8. So I'm thinking both of those are going to be negative numbers. That's going to be x minus 3 and x minus 5, because negative 5 plus negative 3 is negative 8. Negative 3 times negative 5 is positive 15. Then on the bottom, we're doing that same method. So what multiplies to get positive 25, but adds up to get negative 10? That's going to be x minus 5 and x minus 5. Okay, now let's go back to that top. So we have our x squared term is second, and that generally tells me that I want to take a negative number out because I want to switch the places, because you can see everywhere else here our x is our first term. So if I take out a negative 3x on that top, it's going to switch things around. So that's going to leave me with an x. And then that's going to turn that first term into a negative, and we'd be left with a minus 5. Okay, so from here, let's take a look at what the problem is asking us, because they want to know multiply and then identify all the values that make it undefined. So remember, that means that what numbers do I plug in for x in order to get a 0 in the denominator? So we're going to be dealing with this, this, and this, because the other two are the same. So for that first term, if I plugged in x equals 3, I would get a 0. For the second part, I would plug in x equals negative 3, and for the last one, I would say x equals 5. Okay, so if I plugged any of those things in, then I would end up with a 0 in the denominator, and the whole problem would be undefined. So what we do after we find those, so remember x cannot be equal to any of those numbers, and now we just cancel things out where they meet on the top and bottom. So our answer would be those undefined values, and then what's left over in the end. So that negative 3x all over x plus 3. Okay? So here in our problem, we have x plus 4, and then x squared minus 4x, and then that's being multiplied by 2x squared minus 9x plus 4, and that would be over 1. So that's the one little trick to this one. So when it says multiply, just simply multiply, our answer is going to be some sort of rational expression. Okay, so the first thing, I'm just going to deal with what we have going on. And that's going to be x squared minus 4x. So I can take an x out of that. So that means that I would have an x minus 4. And now we have to figure out how we can factor this guy over here. So what multiplies to get a positive 4 adds up to get a negative 9 in the middle, and we have a 2 out front. So I'm going to stick that 2 with one of my x terms. Now here's your initial thought. Since I know I'm probably going to be canceling something out with a x minus 4, I'm going to try that first. So that means if that's negative 4, this has to be negative 1. So in order to check this, I'm going to refoil this out. So that's going to be 2x squared minus 8x minus x plus 4. So these two things are going to give me that -9, so I know that that's right. And then since all we're doing is multiplying, we can just cancel things out. So that means I'm going to cancel this with this. And then what we're going to have left here is an x plus 4 times a 2x minus 1 all over x. And if you want to leave that top part in those two separate binomial things in parentheses, that's totally fine by me. You do not have to simplify things for me more than that. Okay, and that'll be the end of our first part. Sorry, this one was a little bit longer.